I'm going to show you how to make a tic-tac-toe game in Python. And the whole point of this is for you to learn 2D arrays. And it's actually, well, the implementation of this in Python will be a list of lists. Now, before you get started, before you watch any further, I'm just going to warn you, let you know, this is an assignment, not a tutorial. So by the end of the video, you will not be shown entirely how to finish the tic-tac-toe game, only how to set it up, and then I'm going to leave it to you to work out some of the details. So if you're looking for a full tutorial on how to complete this game, you might want to find a different video. I don't want to waste your time. Okay, so at the end result, by the time you are done, so I did finish the program, although I'm just not going to show you all of the details. It's going to ask you to, you're the player, so you're going to enter which row that you want to do your entry. So let's say I choose 1, and which column, so let's say I choose a 2. So notice it put an X in row 1, column 2, and then the computer at random chose where to put its O. So now for my next move, let's say I made a mistake here and I chose to go row 1, column 2 again. It'll tell me I must enter an empty square on the board. So I'm going to try 1, 1. And the computer placed its O here. So I'm going to now go row 2, column 1. And now let me give the computer a chance to win here. So I'm going to go row 2, column 2. Oh, and the computer didn't bite. So I'm going to go row 3, column 3. And then it'll tell me the game is over and that X won. So to get started with this, I'm going to show you first how to set up the game board. The game board has to keep track of where the X's and the O's are. And we're going to do so as a list of lists. So I'm going to make B equal to a list. And inside the list, I'm going to have a list. And I'm going to give it these values here. I'm going to have them all blank. And then the next item of that list will be a second list. So each of these lists are going to represent the rows. Okay, and then to print it out, I want to go through here and print these one at a time. I want to go through here and then this row to print out my game board. And I'm going to define a function to do that because we're going to want to print this out repeatedly, so it's easier if we define a function. So I'm going to call this function P for print. And let's just print an empty space first. And then I'm going to write a loop for I in range 3. Okay. So now we're going to loop 3 times, and each time we're going to print out a line. So I can print it out just as a list item. So I'll start out like that, and then I'll fix it up. I'll clean it up into a string after. So I'm going to print my list at I. So the first time through here, I is equal to 0. It's going to print the first item, which is the first list, then the second, then the third. So let me just call that function, and we'll run it here. So as you can see, this is our game board here, and we're just printing out our 3 rows. But they're written as lists. And notice the game looks cleaner here, where without the list formatting, it's just turning it into a string. So the little trick to turn a list into a string is you use dot join. So any character, so I'll use a blank space, dot join. So now this is going to print one row at a time, but it's going to convert those rows into lists. Now, just to see where things are, let's say I was to turn this item here into an X. Okay, you see where the X is here? Watch where the X appears. So that's this one right here. Okay. So let's say instead it was, let's say I wanted to do this one here. I wanted to make this one here an X. Well, let's make this one an O. Okay. So you might want to just change a few things around in there for yourself just to verify what's where. The first list item becomes the first row. Second item becomes the second row. The third item becomes the third row. Okay, so this is our blank board. And so this is how we print it out. Now, one of the things you want to repeatedly do is be able to enter an X or enter an O wherever it is that the user chooses. And I'm going to make a function for that. I'll have a function called X and a function called O. And so let's just define that X function. So I'm going to define X. And it's going to take in the parameters R and C, which are going to stand for row and column. And what this is going to do is it's going to put an entry here. Now we use row first and column second. And I'm going to make this entry equal to X. So if I call, let's say I want this to be row 1, column 1. I'm going to call this function at 1, 1. Now, you may expect 1, 1 to be up here, but you're going to see that it's actually in the middle, and I'm going to explain that in a second. Okay, so if I call x1, 1, it puts an x here in the middle. How do I get the top left corner? It's actually 0, 0. So a Python list, the first item is item 0, and subsequent items are 1 greater than that. So it goes item 0, item 1, item 2, and so on. So this is item 0, this is item 1, this is item 2. Okay, now I need a function as well to place the O's in the board. So I'm going to define O at row and column as B at R C is equal to O. Okay, so after placing an X at 0, 0, let's place an O at 2, 2. Okay, so you can see how we're placing things within our board. And then the way the game works, it asks you to enter another value. It gets the computer to calculate another value, and then it's reprinting the whole board. So it would have something like, I don't know, maybe an X gets value 1, 1. And O can get the value 2, 1. And then just calling P is going to reprint the whole board. So now you'll see the board printed out twice. And in the second version, you see the changes that are made. Okay, now let's write a little bit, a couple input statements so that you can get the user to enter these values instead of having them pre-programmed in. So I can use input statements. And I'm going to say that my row is equal to input enter row. And I'm going to prompt the user to enter a value between 1 and 3. Because although programmer knows things start at 0, a person playing a game typically is going to expect things to start at 1. So we're going to let them use 1, and then we will translate that into our program to turn a 1 into 0, turn a 2 into 1, and so on. Now, we have to do a bit of math to this, so we're going to actually convert it into an integer. So row is equal to int row. That way we can do a little bit of arithmetic to it. And then I can do the same thing to get the columns from the user. So let's have column. And so I'm just going to change each word row to column here. And we're going to get them to enter column 1 to 3. Okay, and then once that's done, we're going to place an X at, I want it to be at where the row and column that they specified. But remember, if the user is entering 1 for the first value, we're going to have to call that row minus 1. So that if they enter a 1, we feed our function a 0. If they enter a 2, we feed our function a 1, and so on. So same thing with the column. I'm going to subtract 1 from that as well. And then let's print this out to see if that worked. Okay, so enter row. So let's say we have row 1 and column 1. So this should show up in the top left corner, which it does here. So if I did not subtract 1 from here and from here, it would put it in position 1. And remember, this is position 0, this is position 1, this is position 2. And this list here is row 0 in here, or as the person would enter row 1. This here is row 1, or as the person would enter row 2. And this is row 3. This item here is row 1, column 1. This is row 1, column 2. And that's row 1, column 3. Again, as referenced by the user, not the programmer. The programmer is starting at 0. Okay, so now how do we get the computer to enter its value at random? So we need to import random, which will give us access to Python's library that produces random numbers for us. So we import random, and then I'm going to say that column is equal to random dot rand int 1 3. So column is going to take on a random integer somewhere between 1 and 3. And I'm going to get row to do likewise. Let me just change this. Okay, here we go. So I'm going to get row equal random dot rand int from 1 to 3. And then I'm going to place the computer's O at row column. However, I run into the same problem. Since row and column went from 1 to 3, and inside the computer, we've got to convert those to values 0 to 2. I'm going to subtract a 1 from each of those. And then I'm now going to print that off. Okay, so let's give this a try here. Okay, so we have 1, 1 for us, and then the computer put theirs down here in the bottom corner. Let's rerun it. So I can show you these things are going at random. Now, I wonder if there's some issue with the random generator on here. I may just run Python locally if, oh no, there we go. I guess that was just coincidental, but that it placed the first 3 tries into that bottom corner. Unlikely, but it'll happen. Okay, so I'm putting my X in the middle, and it puts its O in the top right corner, or I'm going to put my X in, let's say, row 1, column 3, so that's top right, and then it's putting its O into the bottom right. Now, this is a start. There's a few problems with this. One problem is if I put an X here, in the game of tic-tac-toe, my opponent is not allowed to put an O over top of it. However, I haven't done anything to ensure that that'll happen. So it's perfectly possible at this point for my opponent to overwrite my value. So we need to check to make sure that that space is not already taken. Also, for the game to continue, all of this has to be in a loop. So the user enters the row and column of where they want to play, and then the computer generates the random value for it to make its entry, and then we want that to repeat. So this portion here where you take the user's entry and then where you generate the computer's random entry, that has to be in a loop so that this repeats. You're going to want that loop to end under one of three conditions, either when the board is filled, or when X wins, or when O wins. So you want to look to see if there's a full row or a full column of X's, a full row, full column of O's, a full diagonal of X's or a full diagonal of O's. And you also want to check to see if the thing's completely full. Now, checking to see if it's full is quite easy. All you need to do is set up a variable to keep track of the number of moves that are made. And if the number of moves hits 9, that's it. There should be no 10th move allowed. What I do want to explain in clear detail, because I don't think it'll be entirely obvious to you, is how to check a full row, a full column, or a full diagonal. And that's really the reason why this tic-tac-toe game is a good place to start when you're learning about two-dimensional arrays, because it allows you to navigate the location of the data structure very clearly. Or it forces you to navigate the location in the data structure very clearly. Okay, so first of all, let's check to see if a move is legal. So before the opponent makes its move, or actually before you make your move, you see how here it places an X in row -1, column -1. So how about we have an if statement instead? So if our board at row -1, column -1, if that's equal to a blank spot. So if that entry is blank, then we're going to place a value there. And if it's not, well, we'll want to tell them they must enter in an empty space. You must place X in an empty space. So if indeed there's a dash there, then that's legal. It'll place the X there. If there's no dash, then we want to tell them they must place X in an empty space. Now, that board's starting out as blank, so let's say we're partway in the game, and so there's an X here. And verify that this works. Okay, so right now there's, and let's print that out just so that you can follow this a bit easier. There we go. So let's say we're at this stage of the game where there's an X here, and let's say I try to go into row 1 and column 2. It's going to tell me I must place X in an empty space. Now, the way this worked, I've just lost my turn. It placed an O there immediately after. So you're going to put that inside of a loop to take in the opponent's entries and your entries, and then within that loop, you're going to want yet another loop to, we call this validate your data. Make sure when they enter a value that they're entering coordinates that are allowed. Another way things could go wrong is what would happen if they tried to enter row 5, column 6. It's going to give me an error because I'm out of range. You see, I have a list, and my list has 3 entries, and each entry has a list of 3 entries. So if I put in values that go beyond that range of 0 to 2, it's going to tell me that I'm out of range. So I can further validate my data here by having a look at this if statement. I'm checking to see if it's blank. And let's also check and row is less than 4 and column is less than 4. So now it's only going to try and place a value if my row is a value from 1 to 4, my column is a value from 1 to 4, and the spot that is trying to put it in is empty. And so I'll put that in my else statement here. That indicates to the user that the entry was not good. So let's say I go 5, 5, and it should tell me so let me put brackets around here. Not sure why this if statement's not working. And column is less than all right, let's try that. Okay, so it's telling me I am out of range. So it looks like it is, oh, I see the problem. We're out of range here, and then it's checking to see if there is a value there. Yeah, let me explain the problem here, and then we'll immediately fix it. So in checking to see if the data is valid, I'm checking to see if I'm trying to enter my X or O in a blank space, and then I'm checking, in addition to that, so I'm checking if the space is blank, and then I'm checking if the space is within range. The logical error there is I'm checking to see if it's blank, and then I'm checking to see if it's even on the board at all. So if I enter a value like 5, 5, that would put me over here, and I'm checking to see if it's blank before I even check to see if it's on the board. That's why I'm getting an error, because I'm looking for a value that's not there. So the way we'll fix this is first we'll make sure that the values, so I'm just going to cut this section out here. And I'm going to move it up above. Okay. So now only if the row is less than 4 and the column is less than 4 will we even check to see if it's blank, because just checking there. Now here we can say that it must be in an empty space, and I'll have an else condition under this and let them know row and column must be 1 to 3. There we go. Okay, so now if they say row 5, column 5, it's going to say no, row and column must be 1 to 3. And then let's say I do this correctly, so I've got row 1, column 1, then it's going to place the X there. Let's say I try row 1, column 2, now it's going to say no, it must be in an empty space, and as you can see, that space is not empty. Now, I know this kind of looks wrong because I've already placed an X there. Let me place an O there. It might look a little more realistic here. Okay, there's an O there. So if I go 1, 1, it gives me an X. If I go 1, 2, it's not going to let me place an X here because it's not an empty space. And then if I go 5, 7, it's not going to let me do that either because it's got to be in rows 1 to 3 and columns 1 to 3. Okay, so you need to put all of this inside of a loop. And in addition to putting that inside of a loop, you need to have the entry as a loop within a loop, so that you're going to ask them, the user, to enter a value. If it's not valid, you want to loop again back and ask them to re-enter the value. You keep asking them to enter the value until they enter valid data. And then you generate the computer's random number and keep checking to see if the computer's entry is valid. Once you have a valid entry and the computer has a valid entry, you're then going to want to check to see if there's a win. And then you want to loop around, see if there's an empty space at all, and then run the whole process again. So you're going to have two little loops inside of a larger loop, and you're also going to check values as you go. So I'm going to outline that with a flow chart, and then I'm going to let you go ahead, work on this, and I wish you the best of luck. So in our larger loop, so let's just call this loop. And I know you're going to put while. You can put while true, so you have this endless loop running, and then break out of it with a break statement. So we're going to have a loop, and we're going to check is board full, and if yes, then you're going to want to break out of there. And if the board is not full, then we're going to start another loop. And within this loop, we're going to from user. And then let's check. Is X valid? So X will be valid if the space is empty and the space is 1 to 3. So tic-tac-toe game. Let's say there's already an O here and an X here, and so now it's X's turn. If they try and put another X here, that's not valid. If they try and put an X out here, that's also not valid. So if they pick a valid square, and so is X valid? And if it is valid, then we're going to break out of here, and we're going to get the O value. If it's not, so that'll be yes. If no, if it's not valid, then we want to loop around and try again to get an X value. Also, after X went, we're going to need to check, did X win? And if they did, then we want to break. But if they did not win, then we have another loop. And in this loop, we're going to get O value, get O from random. So we're going to generate some random value for O, and then we have to validate it. Is O valid? And if it is, if the answer to that is yes, then we want to break out of our loop, check, did O win? And if they did, then we want to break. And if they did not win, then we want to loop around back to this main loop. Now, if the O value is not valid, then we want to loop back here and check again. So let me sort of highlight what's happening here. So yeah, that needs to loop back to all the way to here. Okay, so let me highlight it. So our game here starts out, is the board full? If the board is not full, then we're going to loop here. So the board is not full. We're going to loop here, get an X value. Is X valid? So let's say they put X in a not valid spot. We're going to loop around, try get another X value from the user. If it is valid, then we're going to check here. Did X win? If they won, the game's over. But if they did not, then we're going to loop here. We're going to get an O value from the random numbers in the computer. Is it valid? No, we try again. If it is valid, then we get out of there. We check to see if O won, and if they did, our program is over. But if they did not, we need to loop around, check if the board is full, and repeat the process. So you are going to take this, you're going to put this portion here where the user and the computer find an X and an O value, and you're going to put that into a large loop. Within that loop, the individual part where the person enters a value has to be in a loop, and the individual part where the computer generates a value also has to be in a loop. Within each of those loops, you want to check to see if their entry is valid. If they are, you go on. If they're not, then you need to escape. Sorry, if they are, you move on. If they're not, then you need to go back into the loop to keep asking until you get a valid value. Now, the one thing I didn't really explain is how do you check did X win or did Y win? So you've got a tic-tac-toe board, and this is row 0, row 1, row 2, column 0, column 1, and column 2. So a scenario where X wins is when all of a row or all of a column or a diagonal is all equal to X. So there are more elegant ways you could do this, but I'll just show you the most straightforward one because you're starting this out. So let's say we want to check this condition here. So that would be if my board at 0 is equal to X. So I'm checking if, sorry, if my board at 0, 0 is equal to X. So that's row, and put that in quotes, that's row 0, column 0, so that's the top left corner. If that's equal to X, and my board in row 0, column 1, so we have concatenated square brackets. The first one will tell you which row, the second one will tell you which column. Is equal to X, and if my board in row 0, column 2 is equal to X. So if all of those are true, then the winner is equal to X. So this would be a way of checking if X won in this particular way. Now there are 1, 2, 3, 4, 5, 6, 7, 8 different ways to win. So there are 8 different lines that have to be done to check to see if X is won. Okay, I'm going to stop it right there, and best of luck.